So like we put on our periodic table, an oxidation number is just another way to say charge. So for any ion, that's going to be an atom or a group of combined atoms that has a charge because of either the gain or the loss of electrons.
So when you're writing, like, will you pull that up on Thursday?
Yes, of course.
Thanks.
And so for example, any of these that we wrote would be examples of ions that formed because we gained or lost electrons. Bye. So another example would be oxygen with a -2 charge. It got that -2 charge by gaining 2 electrons. And then the oxidation number, again, is just the charge on an ion. When we talk about elements that have predictable charges, we are talking about elements that are in groups on our periodic table that we have labeled the charges for, meaning any element that's in this group will have a +1 charge. This group will have a +2 charge. We call that a predictable oxidation number. We skipped the entire D block because these don't have predictable oxidation numbers for the most part. They have variable oxidation numbers because they have varying numbers of valence electrons. This group is called the transition metals, and we'll talk about that a little bit later. They are all a type of metals. And if we look at where they're situated on our periodic table, we have +1 charge, +2 charge, unknown charge, and then +3 charge. This is kind of your hint to lump those in with the positives, that these are going to be positively charged. So for the most part, bless you, metals are going to be positive cations and nonmetals are going to be negative anions. We also talked about metals versus nonmetals briefly before, but just as a reminder, your zigzag line denotes the separation between metals and nonmetals. I guess technically it probably goes like this, but we don't really deal with this bottom row anyway. So this side of your periodic table is going to be your metals, except for hydrogen, which is a nonmetal. If I'm looking at this. So any of them that are outlined in orange will be your metals. Zoom it out a little more. These are kind of metals too. And then all of these on this side of the zigzag line and hydrogen count as nonmetals. Your nonmetals in general have negative charges, which you can see by what's labeled as the predictable oxidation number, but hydrogen has a +1. That's why it's sitting there. So if we come back to this page, it's just reiterating what we've already been practicing, that atoms will gain or lose electrons to get 8 electrons in their valence shell. The octet rule tells us that atoms always want a full valence shell. And then the exception to this is if it's stable in energy level 1, that means that it only has 2 electrons, because energy level 1 only has the S sublevel, so that's maximum 2 electrons. We wrote that on the front page, but I'm going to put it here again. Energy level 1 only needs 2 electrons to be full. Just to show you where that is before. So we already wrote that exact same thing. Energy level 1 only needs 2 electrons to be stable. Means the same thing as full. So this kind of breaks it down into metals versus nonmetals. Remember that your group numbers are just talking about counting them straight across. So we go from group 1, group 2, that's going to be this group and this group. This is technically group 3, and then group 4, and so on. Group 13 is the one that has 3 valence electrons, and then 14, 15, 16, 17, and so on. So that's what those are talking about. So for group 1, we have 1 valence electron. That's this group right here. The oxidation number is going to be +1. And the type of ion, that's asking, is it a cation or an anion? Meaning, is it positive or negative? If it has a positive charge, we call that a cation. Remember that cats have pause? A cation is a positively charged ion. You can also say that cats are losers. It got that way by losing electrons. Group number 2 is the one right next to it, so 2 valence electrons. This one had a +1 charge. This will have a +2 charge. So 2 valence electrons +2 oxidation number, and it is also a cation. Notice that we skip groups 3 through 12. These are what we call our transition metals. They are also cations, but they have variable charges. So they're going to be positive, but the actual number associated with it changes. Group 13 is this next tall one. This has 3 valence electrons and a +3 charge. What type of ion would we call that? A cation. Group 14 is sort of our special one. Group 14 has 4 valence electrons. That's when it's just as easy to gain 4 as it is to lose 4. So it can be a +4 or a -4 charge. So this does tend to confuse students as well. So with 4 valence electrons, it can either be +4 or -4, but that does not translate to neutral. It's not going to be both plus and -4 at the same time. It's going to do one or the other. So it's either going to be a cation or an anion, depending on what it's doing. But it's not that that balances out. It's not that that's no charge. It just is that it depends on what's happening. So this is going to be neither. Or sorry, either. Not neither. EITHER. And then group 15 has 5 valence electrons, 16 has 6 valence electrons, 17 has 7 valence electrons, and 18 has 8 valence electrons. 5, 6, 7, 8. It matches 5, 6, 7, 8. So this is the distinction between when they are losing electrons to become positive or gaining electrons to become negative. So 5 valence electrons, you would gain 3 electrons, which means you'd have a -3 charge. So it goes -3, -2, -1, and then there is no charge for your group 18 noble gases. So the type of ion that this forms is what I was thinking of up here. This one would be neither.